Hey everyone, it's Emil with the Oliynyk lab again. Today I'm going to do a quick little tutorial on using composition analyzer Featurizer, and this was recently featured in Digital Discovery here. So a couple of quick things. So you're able to generate compositional Featurizers, and we currently support binary, ternary, quaternary formulas as with the Oliynyk elemental properties. And there's a couple of different options here. Firstly, we support a broad amount of elements, and the focus was on solid state intermetallics. So to get started, it's very simple. You just open up your terminal. I X'd out. So you open up your terminal just like this. Let me resize that. And you just follow the steps in the command line. So I like to do it in downloads because I'll just get rid of it. I already have it. So you download the code just like this. And then you navigate to the directory. And we're in download, so you just do that. And this was just recently refactored into an app by Bob. So you do pip install composition analyzer Featurizer, and I like to use Anaconda environments, and that's just a way to manage your sort of libraries, and I'll have another tutorial on how to set those up sometime later on. So the name of my main environment is this, and then you install the package, and obviously I already have this installed, so all the requirements are satisfied. On your end, it'll take maybe a maximum of 3 or 4 minutes or so to install them, and then you just do python main.py. So I'll split this up into 5 different parts. So the first part, the filtering chemical formulas and generating a periodic table heat map. That's part of the filter and analyze section. So we just select option 1. So it's very intuitive, all command line. Do you want to filter an Excel sheet / folder of sifts, or do you have a filtered sheet ready? So because we're starting from the ground up, we're selecting 1, and there's a couple of different demos already prepared for us. We have a PCD folder and then an ICSD, and these are what we currently support at the moment. So I'm just going to select the PCD files, and it prints the tables and saves it over to here. So it sorts the elements, right? And then to summarize it, we just select the one that ends with sorted. So it summarizes, filters, errors out, and it also allows you to filter based on numerical or elemental composition. I believe they're all binary, so it'll end up being the same. So let's just select yes here. So numerical filtering will separate based on unary, binary, ternary, quaternary entries. We don't support pentary entries yet, while elemental filtering will remove entries with elements that you don't want. So since one will be the same, let's just filter out something like antimony. So you're able to input the elements separated by commas. Let's just filter out antimony, see what happens. Filtered entries saved to this, and then removed entries saved to this. So when we look through, we have a couple of different things. So let's see where we start off. I'll just open all of them. Opening up in my other window. Let's start off with the first one. So the sorted will be the first. So nice little Excel sheet, right? It goes over each of the entries. Gives you the formula, the first element, the number of elements, second element, number of elements there. We also have a sorted element count, so something much simpler. It tells you how much of each element that you have in the folder of your SIF files. And then we also have the filtered one, and this will get rid of the errors. It'll tell you what the errors are. If it's not here, obviously they'll all be considered later on, and nothing displays for the error, and they're all binaries. And we also have the summary, which is in this case going to be the same one pretty much. And then we have the ones with it removed and the filtered ones. So anything, if you remember, we removed antimony. So the removed ones all have antimony, obviously, either in element 1 or element 2, whereas our filtered one does not have antimony at all. And then finally, we generate a periodic table heat map. Unfortunately, at the time of recording this video, I realized that we have an error with the actual coloring, and I've just opened up an issue on GitHub, so that should be fixed very soon. But you know, they should be different colors corresponding to the different counts, and it would look something like this. Anyways, this summarizes the first option, and I will be going through the second option shortly. Alright, so in this part, I'm going to go over to sorting the chemical formulas in an Excel file. So this works through by looking through each file that has formula in it. So we could sort by stoichiometry, property, parsing, or custom label. I'm going to select property. And let's do, I guess this one. So, let's see. We can sort by atomic weight, atomic number, period, group, and wave number. And the purpose for this is that sorting by elemental properties obviously will affect your overall predictions for machine learning if you're clustering, mainly if you're doing regression, or if you're doing, I say, classification, whatever it may be, there's going to be an effect. So let's say we want to go by something simple, atomic weight. Would like to sort in ascending or descending order, and these will also have their own effects. Let's just do yes, convert indices into fractions. I'll do no in this scenario. And then it's saved pretty intuitively, summary by property AW. And so let's open that up. Perfect. And how that is changed from the original one to the left. And so there's definition stored as to, you know, the values of atomic weights, all these properties within the actual sheet. So we could see already. Let's redo this with maybe electronegativity. Property. What was it? Summary. Yes. Let's do bulk modulus. Descending order. Yes. Yes. And let's open that up. See how that's affected. Assorted formula. Yes, that's what I was looking at. Okay, yeah. And we obviously some differences. Good, fine. All right, and then that pretty much wraps up option 2. So in this section, I'm gonna go over option 3, and that's the actual featurization process. So you start off with Python main.py again. It'll prompt you to create compositional features for formulas in an Excel file. So we're going to do the sorted Excel file by bulk modulus that we did in the last session. So we're at 7. Default is no, so you could just click enter and that'll signify no. And it's as easy as that. And now let's see, where is it? We have a binary as well as a universal sort of property set, and that's dependent on the different formulas that you have. So we're dealing with strictly binaries, so the binary and the universal I think should be roughly the same. So we have formulas, index normalize of the first element atomic weights, unpaired electrons, and we go on and go on. This is all based on the Oliynyk property data set, ionization energies, weighted, so on and so forth. And we have a total of almost, let's see, upwards of a good amount of feature. The documentation says all of it. And likewise, we could increase it based on the mathematical operations, and that is as simple as it gets. Now, to keep in mind, it does only read it if there's only reads Excel files in which there's a formula column, right? So if we look through the sorted by bulk modulus, and it's reading this, it's only reading the formula because it gets it directly from here. Now, it doesn't sort it differently. We sorted that yesterday using option 2, and that's it for this section. Now in this section, we're going to go over option 4, which is to match CIF files in a folder against an Excel file. So this comes in handy in which you're looking for missing CIFs in a folder. Let's say you have an Excel sheet of whatever you need, of all the featurizers. You want to make sure you have all the CIFs, you're not missing any, you didn't move any. And there's other handy use cases. So, for example, a PCD1 will have, I believe, 20 CIFs, right? And for example purposes, you know, we could, I guess, check this. So, or we could check this. And it's likely we should, you know, we have 20 and 20, there shouldn't be a problem. So we will select option 4, we'll do the PCD files, and this one will be PCD elements sorted. And that'll be number 1. And it also allows you to pick the sheets. 0 entries from the Excel sheet are missing. Missing CIF IDs saved to missing files.csv. And it also gives you the paths of unmatched and matched sheets, and the filtered Excel sheet as well. And that's pretty much it. Comes in handy. We figured why not include it. So for the final option that we offer, we're able to merge 2 Excel files, and it's nice because we're able to see that there is steps. So we provide an Excel file that contains CIF IDs. It'll match the column called entry and merge it with another featurized Excel sheet, and both of these have to have CIF entry numbers. So just as an example, you know, we'll do sorted summary by property bulk modulus, as well as by atomic weight, and we can see how that displays. Certain use cases will be like if you want to merge 2 different featurized sets and whatnot. So I already ran through this. So let's say we choose by bulk modulus, and you pick the sheet, and then by atomic weight, select that sheet as well, and then you end up getting bulk modulus, sorted, and then AW merge. So it works pretty intuitively. It just names the file based on the 2, and that will be right here. Perfect. Yep, so it pretty much appends. Yeah, pretty much appends it, and if you want to take a look at them individually, we could do that as well. Where am I? So as you can see, it pretty much just appends it. Entry, formula, element 1, so on and so forth. And we just want to make sure, you know, we dot our I's, cross our T's, and make sure we could offer as many things as possible, and that's how this ends up working. So as a correction, we do offer 133 features for our binary structures, 205 for our ternaries, roughly 383 for our quaternaries, and universally we offer 158, and this applies for binary, ternary, and quaternary structures. And I know I was between 198 and 98 roughly, what I had previously mentioned, but these are the correct numbers. So this pretty much concludes a very brief tutorial as to how to use our composition analyzer Featurizer. It's very intuitive, and we ended up creating it to make sure anybody can use it without a relevant coding background or a computational science background or computational chemistry, whatever it may be, and to make sure, you know, machine learning is very accessible to anyone that wants to get into it. And if you'd like to contribute, you can feel free to make a pull request or open up an issue if you run into any problems. And anything at all, feel free to reach out and even leave us any comments down here, or directly to the email would be better. And I'll make sure I link the GitHub page as well as the lab website if anyone would like to reach out or do anything from there. So thank you again for viewing the video. Feel free to leave any comments if anything is unclear, and that'll pretty much summarize it here. So I do want to thank everyone in the lab, Alex, Dr. Oliynyk, Danila, Nikhil, and Sangjun for their contributions on this project. It worked very swell, and it was really overall a great project to complete.